Okay, here we are again looking at Chapter 8, torque problems, and I'm specifically looking at the example problem 8.2 found on page 244. This is a case where you have a door, and we're looking at the torque exerted by a person when they are opening the door, but they're pulling on the handle at 60 degrees, and they're pulling with a force of 300 newtons. Now, there's two ways to solve the torque on this. One, we can take this force and resolve it into its perpendicular component by using 300 newtons times sine 60, and that will give us a perpendicular force. And then once we have that, we can use our torque equation of R times force. And we get 2 meters times 260 newtons, which gives us 520 newton meters. The other way we can look at it is we can look for what the lever arm is. And when we're looking for the lever arm, we can extend our force backwards like this, looking for the radius so that we create a circle that this force is tangent to the circle. Or another way of looking at it is this side forms a 90-degree angle with the force extrapolated down this way. When we do that, we know that we have alternating interior angles here. So if this is 60 degrees, then this is also 60 degrees. And then we have the door of a length of 2 meters as the hypotenuse. So we can take 2 meters times sine 60 to give us our effective lever arm. And then we end up with our force of 300 times our effective lever arm, which is 1.73, which gives us a torque of 520 newton meters. Either way, it gives us the same answer. And it's just two different ways of looking at where the force and the perpendicular force is here, or where the effective lever arm is here. Part B to the question asks, if we put a wedge 1.5 meters away from the hinge, how much force would that wedge have to produce in order to prevent the door from opening? And so if the door is not rotating, we have static equilibrium, and therefore your net force has to be 0. So here again, we have it drawn out. Here's the hinge. The door is 2 meters long. We have 300 newtons pulling at 60 degrees. We do not have to recalculate this. We already know that's 520 newton meters. We have a wedge here that is 1.5 meters away from the hinge, and that is going to produce a clockwise torque, which would be negative. The torque we calculated earlier is creating a counterclockwise torque, which is positive. So when we add this negative torque to this positive torque, it has to equal 0. So here I have my torque equation for the wedge, which would be 1.5 meters times the force of the wedge. And that's a negative 1.5. And so then when we add this to both sides, we get 1.5 times FW equals 520 newton meters. This negative sign shouldn't be here because we added 1.5. The negative sign should have been here, and this should not have a negative sign. Then we divide both sides by 1.5, and we get a value of 347 newtons. I hope this was of value to you in figuring out torque problems. We'll talk to you again later.